Notes 1.8 are on the properties of parallel lines. We're going to begin by drawing two lines. I have two lines on the left, A and B, that are being intersected by line T. Line T is called a transversal because it's intersecting two or more lines. On the right-hand side, I have lines C and D. Line F intersects lines C and D, so line F is a transversal. A transversal is a line that intersects two or more other lines. The space between the lines is called the interior space. So between lines A and B, I'll label that region interior, and then outside of the lines is called the exterior. The same is true on the right side with the other diagram. The space between lines C and D is called the interior, and the exterior is outside of that. So to the left of C and to the right of line D. I'm going to label some of the angles that were created here. So at the corner on the left here, I'm going to label that angle 1, angle 2, angle 3, angle 4. Then go down to the other intersection and we're going to label those angles 5, 6, 7, and 8. We have special angle pairs in the diagram. The first set are called alternate interior angles. The angles that are alternate interior are on opposing sides of the transversal and they're in the interior. So that would be angles 4 and 6. That's a pair of alternate interior angles. And the other pair of alternate interior angles are angle 3 and angle 5. We also have alternate exterior angles. Alternate exterior angles are on opposing sides of the transversal, but they're on the exterior. So angle 1 and angle 7 are alternate exterior. Then angles 2 and 8 are a pair of alternate exterior angles. Corresponding angles, those are found on the same side of the transversal. Look at angle 3, then look at angle 7. Angle 3 and angle 7 are corresponding angles. If I extend angle 3 a little bit more, the pair of angles take on the shape of a letter F. Now the other ones take on that shape also, but it might be flipped over or upside down. So I'll start to list them. Angle 3 and angle 7 are a pair of corresponding angles. And then angle 2 and angle 6, there are two more on the other side of the transversal. Angle 4 and 8, and then angle 1 and 5. Another pair of angles are called same side interior angles. Same side interior are angles 3 and 6 and angles 4 and 5. The last pair I want to point out are same side exterior angles. Angles 2 and 7 are a pair of same side exterior, and angles 1 and 8. So that was an introduction to the vocabulary we have for this section. Alternate interior angles, alternate exterior angles, corresponding angles, same side interior angles, same side exterior angles. What's special about these pairs of angles happens when the lines are actually parallel. Parallel lines are lines in a plane that do not intersect. If I were to draw two parallel lines, and I would like you to know that they're parallel, then I would label them with extra arrowheads like that. I could do single ones or I could do double ones, and that's my communication that I have parallel lines there. If two lines are parallel, then the alternate interior angles are congruent. Here's a picture for you. I'll draw two parallel lines, I'll draw a transversal, and then I'll mark alternate interior angles congruent. So we have that pair that would be congruent, and then we have this pair that would be congruent. If two lines are parallel, then alternate exterior angles are congruent. Here are two parallel lines. Here is a transversal. Alternate exterior angles are here and here, so those two are congruent, and the only other pair is here and here. If two lines are parallel, then corresponding angles are congruent. There are several pairs of corresponding angles. There are 4 of them. Here's one pair that is congruent. Here is a second pair that are congruent. This one is congruent to this one, and then that one is congruent to that one. If two lines are parallel, then same side interior angles are supplementary. For this, I will have to use angle measures. So this angle could be 120, then this one would be 60 because they'd have to be supplementary to each other. Also, same side exterior angles are supplementary. So there are some diagrams to go along with those rules. Those are called theorems. Our diagrams also create pairs of angles called vertical angles. Vertical angles are created whenever two lines intersect. So you do not even need parallel lines here. You just need two lines to intersect. The angle that's formed up here is a vertical angle to the one down here. And we know that vertical angles are always congruent. So I write vertical angles congruent. So the top angle is congruent to the bottom angle, and then the left angle is congruent to the right angle. Here is an activity which gives you an opportunity to pick out the angle pair relationships. So in the first box, you're going to identify which angles are alternate interior angles. That means they're going to be on the interior between the lines, and they're going to be on opposite sides of the transversal. One of the pairs would be angle 3 and 6. 3 and 6 are alternate interior. The other pair of alternate interior angles are 4 and 5. Now I would like you to pause the video and identify the rest of the angles in these diagrams. Then turn the video back on to check your answer. Next, we have a fill-in-the-blank activity. In problems 1 through 6, we're looking for the vocabulary terms from up above. Either you're going to use the alternate interior angles, alternate exterior angles, corresponding angles, same side interior angles, or same side exterior angles as your answer. So please pause the video, do 1 through 6, then turn the video back on to check your answers. Scroll to the next page. In each of these diagrams, is line M parallel to line P? If yes, explain why. So now we're going to practice knowing those angle pairs, but in reverse. We're not being told that we have parallel lines. Instead, we have to explain or prove why we have parallel lines. In part A, I notice that I have interior angles on the same side of the transversal. So those are same side interior angles. Their measures are 180, and if you add that up, you'd get 180. That means the two angles are supplementary. So that makes these lines parallel. Yes, M is parallel to P because same side interior angles are supplementary. Part B. I have same side exterior angles. 101 plus 101, though, is not 180. So they are not supplementary. Therefore, the lines are not parallel. Part C. You can approach this problem a couple of ways. You can recognize that 120 has a vertical angle right here that's 120, and you can use that. If you like that, if you like vertical angles and you use the 120, you can do this problem like Part A. 120 and 60 are same side interior angles, and they add up to 180. Therefore, the lines are parallel because same side interior angles are supplementary. Or, instead of drawing the 120 as a vertical angle, you could have recognized that 120 is right next to a 60-degree angle because they are adjacent angles and they are forming a straight angle. So if one of them is 120, the other one has to be 60. And if you have the 60 there, then you could look at the other 60. Those two 60-degree angles are alternate interior angles. And if alternate interior angles are congruent, then the lines are parallel. So you get to pick which reason you want to write down. Number 2, name 8 pairs of congruent angles and 4 pairs of supplementary angles by using parallel lines. So in this one, we are being given the parallel lines, so we can conclude that there are congruent angles here and there are supplementary angles here. So pause the video and fill out these 12 pairs of angles, then turn the video back on to check your answers. The first 4 pairs that I wrote are congruent because they're corresponding angles. And then the next 2 pairs are alternate exterior angles, and 3, 6, 4, 5, these guys are alternate interior angles. The supplementary angles are the same side interior angles and then the same side exterior angles. The next question asks us to apply things that we've learned so far. We know from the beginning that line E is parallel to line F and that line G is parallel to line H. And we have more than one transversal in the picture, so that can become a little difficult to look at. What I'd like to do first is look for alternate interior angles. If I think about line G being parallel to line H, and then that the slant here is the transversal, that created a 31-degree angle on the right, and that means angle 3 over here, whose alternate interior to that, is also 31 degrees. I can do the same thing with the 24-degree angle. If I focus on line E being parallel to line F and the same transversal, the diagonal transversal, created this 24-degree angle. That means angle 1 is also 24 degrees because angle 1 is alternate interior to that 24-degree angle. Other angles I need are angles 4 and 5 and 2 and 6. So if I look at what I do have, I'll look in the bottom left corner near angle 2. I already have a 31-degree angle. I have a 24-degree angle. If you add those up, you get 55. So angle 2 then is going to be supplementary to that 55. So what is 180 minus 55? 180 minus 55 is 125 degrees. So angle 2 is 125 degrees. Now look to your right of that. Angle 2 is on the right side of line G. Line G is parallel to line H. And I'm going to pretend that I'm looking at this transversal now. Line F is going to be the transversal cutting through those 2 parallel lines. That makes angle 6 congruent to angle 2 because they are corresponding angles. So angle 6 is also 125 degrees. I still need angle 4 and 5. Angle 4 is a vertical angle to angle 6. So angle 4 is also 125 degrees. Now to find angle 5. Angle 5 is created from line G and line E. Since I know I have a 55-degree angle down here with angle 3 and the 24-degree angle, I know that's 55. I'm going to use line E parallel to line F and think about same side interior angles. Angle 5 is going to be supplementary to the 55-degree angle, so that is 125 degrees. You could also look at angle 5 as being a corresponding angle with angle 2. So angle 2 and angle 5 are corresponding angles. Then they will have the same measure. So angle 5 now I can write over on the left is 125 degrees. Angle 2 is 125. Angle 1 was 24. 3 was 31. 4 is 125. And 6 is 125. That one diagram allows us to practice almost all of the angle pairs that we learned about. Here's another similar diagram with some different numbers in it. I would like you to pause the video and try to figure out as many angles as you can in this diagram, and then turn the video back on to get some help or to just check your answers. Right away, I'm looking up here. The 68-degree angle is supplementary to angle 4. So I just need to figure out 180 minus 68. That is 112. Notice then, if line C is parallel to line D, then I have corresponding angles. Angle 4 is corresponding to angle 6. So angle 6 is also 112 degrees. There's another corresponding angle for angle 4. If you think about line A being parallel to line B, then angle 4 is corresponding to angle 1. So angle 1 is also 112 degrees. I'm just going to sit here and look at angle 1 is 112 degrees. Next to it is a 23-degree angle, and next to that is angle 5. So those three angles should add up to 180 degrees. Type that in your calculator. 180 minus 112 minus 23, and you'll find out what angle 5 is. Angle 5 is 45 degrees. Angle 5 is an alternate interior angle to angle 3. So angle 3 is also 45 degrees. I just need angle 2. Angle 2 is outside over here on the right. That angle is corresponding to the angle created over here with the 23-degree angle and the 45-degree angle. So add up 23 plus 45, and that will be the same measure as angle 2. Number 5, we have the parallel lines again. Line L is parallel to line M, and line P is parallel to line Q. Name a pair of corresponding angles for L and M with transversal P. L and M are vertical. I'm going to use a highlighter for each of these. So L is here, M is here, transversal P is here. So if I just focus on those three lines, I need corresponding angles for them. The first pair of corresponding angles I see are 1 and 3. Then I see 2 and 4, 9 and 11, 10 and 12. Next, we're going to look at lines P and Q with transversal M. So what you can do with the computer notes is you can erase the highlight that we put on there for the first two lines, and then you can highlight the new lines that we're going to use. We're going to use line P and line Q, and then highlight your transversal M. If we had to do this on paper, you would just redraw the drawing if you needed to. Alternate exterior angles for this drawing with these highlighted lines are angles 3 and 16 and angles 4 and 15. We'll go back to use lines L and M for the next problem. So highlighting L and M and then highlight transversal Q, we're looking for same side interior angles. Same side interior angles are like 6 and 7, and then 14 and 15. And now we're asked if angle 3 is congruent to angle 7, which two lines must be parallel. So let's erase what we have there and highlight angle 3 and angle 7. Here's angle 3 and here's angle 7. Ooh, if you extend 7 a little bit, you get an upside down letter. Do you remember this letter? That's the letter F. That letter F means I set up corresponding angles congruent. Which two lines are touching our corresponding angles? Line L doesn't help make up those angles, so that's not going to be included in our parallel lines. So that means the only other option is P is parallel to Q. Now we can just mark up our diagram. We know angle 3 is congruent to 7, and their vertical angles are congruent also. So 3 is congruent to 12, 7 is congruent to 16, and then I have corresponding angles in this direction. 5 is congruent to 7, 1 is congruent to 3, and you can mark their respective vertical angles. Then I'm going to use a double mark for the other angles. So there's only two measures of angles in this diagram, the way this turns out. 8 is corresponding to 4, and then 15 is vertical angle to 8, and vertical angles are congruent, and it just goes all the way around. So which angles were also marked congruent to 13? 13 is vertical angle to 6, so 6 is probably your first choice. Then there's 9 and 2 at that corner. There's 11 and 4 at another intersection. And finally 15 and 8 are at the last intersection. Now we want angles that are supplementary to 8. Well, 8 is marked with a double arc, so you can just pick out the angles that are marked with a single arc, like 7 and 16, 3 and 12, 1 and 10, 5 and 14. It's time for the closure. Please pause the video and do the closure, then turn the video back on to check your answers.